This video is about testing graphs and equations for functions. For our notes, we'll consider the couple categories we're talking about here and start by testing a graphical representation to see if a graph represents a function. And the one way to handle this is with what's called the vertical line test, which states that a graph represents a function if every vertical line would intersect it at most once. Now, the easiest way to test this out is pretty visually, just kind of drawing some things on our graph. Let's take a look at a couple examples. First, let's consider the example of the parabola that opens downward, intersecting the y-axis at 2, and then opening downward from there symmetrically about the y-axis. If you could imagine briefly just trying to draw some vertical line segments, none of them that you could even imagine would intersect this parabola more than one time. Because of that, we would say it passes the vertical line test, which means yes, it does represent a function. Our second example is that of a line that intersects the x and the y axes, but then cruises going from bottom left to top right diagonally. But again, if you draw some vertical line segments just randomly through that line, you'll notice that there's no way it's going to cross more than once anywhere. And so as well, we would say, yes, this graph represents a function. Our third example is a circle graphed in quadrants 1 and 4, kind of split between the two. But with this one, you'll notice that it doesn't take much. If you just draw one vertical line segment somewhere through the middle of the circle, it crosses twice necessarily, which means if you can draw a vertical line that crosses the graph more than once, we would have to say no, it is not a function. Secondly, let's now discuss how we can test an algebraic representation, or in other words, an equation, to decide whether it represents a function. Now, assuming that we consider y as a function of x, we can do the following. We'll solve for y, and then consider whether any given input for x would produce more than one output. And as a hint, practically, we'll look for a plus or minus in our result. Let's take a look at an example which reads, does x squared plus y squared equals 9 represent y as a function of x? Notice the key order of that phrase, y as a function of x. We're going to explore it with first algebraically and then in a graphing calculator to see how this applies. As we mentioned, our basic steps are to solve for y, which, let me copy our function down as x squared plus y squared equals 9. To solve this function for y, of course, we'll start by getting y squared alone. So y squared would equal 9 minus x squared if we subtract x squared from both sides. Then we'll unsquare or square root both sides, both entire sides of the equation to get y alone on the left side. But as you may recall, when you take the square root of both sides of an equation, we have to introduce this plus or minus on the other side so that we have plus or minus the square root of 9 minus x squared. But there's the step. And unfortunately, it's easy to forget to put the plus or minus when doing this algebraic step. But if you forget it, then you're missing the biggest hint as to whether the equation represents a function or not. And the plus or minus is a clue that it doesn't. And you can verify this because if you were to make an xy table and then pick a value for x, such as 2, if I were to plug in 2 for x, I would have two different results because of the plus or minus. I would have plus square root of 9 minus 4, or in other words, square root of 5. But then for the same input, I could also get minus square root of 5 because of the plus or minus. So one input has more than one output, which violates the definition of a function, which means no, this is not a function. Now let's take a quick look at how a graphing calculator can help us represent this equation, but we have to be very careful about this. We just mentioned that this equation, y equals plus or minus square root of 9 minus x squared, is not a function, and the calculator will only graph functions. So what we're going to have to do in this case is split it up, where the plus root and the minus root go in as two different equations. So in our y1 equals window, we'll start with the positive version. We don't have to actually enter a plus sign, we'll just assume it's positive. So we'll hit second and then our square root button, and then type in 9 minus x squared, which is exactly what we have under the root in our function. And then if we view only this piece, only the positive one, we can do so by hitting zoom, and let's try zoom 6 just to get a nice view of it. It looks to be some kind of like top half of a circle or oval or something. Now if we go back to the y equals equation editor and then y2 equals, so shift down to the second slot. Now let's type the minus version. This one requires us to type the minus sign first, and then square root of the same input, square root of 9 minus x squared. Now if I hit graph with both of these equations, the calculator will graph both of them in the same graphing window. Since I have plus and minus the root, it'll actually graph them both together. Let's take a look at it. And it appears on the screen as an oval, but that's because the graphing window is not square, it's kind of stretched in a rectangular fashion. But you're actually seeing the graph of a circle. But a circle is not a function, which is why you have to split it up and put two different halves of the circle in at one time each, so that the plus is the top half and the minus is the bottom half.